Welcome to qnawire.
So they ask us how do open feed water heaters different from closed feed water heaters? Well, the basic difference is in an open feed water system, the fluids mix, but they do not in a closed feed water system. So I mean, that's the basic difference. But from what the consequences of that difference are is that when you have two fluids that are mixing, you got to have them mixing at the same pressure, right? Because you don't want one to be backflowing on the other. So you come have these two mixing, they got to be at the same pressure as they come in, so that then they're the same pressure as they go out. So that means that you need the uh, the water in the when you have this mixture, you got to make sure that you pump the water, the pressure in the mixing chamber is the same as the pressure in the pump or in the let me see in the I mean, let me see here. Let me make sure I'm saying this right. I need to look at the picture here. I should have just drawn the picture here, so on the in the problem, and let me actually draw it for you. If I can find the picture, let's see here. That's not going back far enough. Let's see here. I'm just trying to find the picture in the book so I can draw a nice little picture for you. Okay, yeah. So in the in the open we have um, turbine, bring it off here, feed water, um, pump, condenser, and then we have coming out of here, going coming out of here, going to another pump, and then going to the boiler, and then going into the turbine. So what we need here is we need the pressure. Um, we need these two pressures to match. Okay, we don't want stuff flowing back into the turbine, and we don't want stuff flowing back into the pump. So we need to have these two pressures match, which means we need that this pressure is going to be much lower than this pressure. So we're going to pump this up so that then they can mix together and then come out here, and then pump it up again to uh, the pressure that we want in the boiler. Now, in the other case, let me actually draw that picture for you. Um, that's a little bit, slightly different. So in the closed case, you have, let's see here, you have turbine, um, condenser, let's see here, to a pump, to the feed water, and then to a mixing chamber, and then to the boiler, and then to the turbine, and then this, let's see here, we have the feed water thing here. And so then this comes out of here and goes through there to another pump and then comes into here. So that's how that one works. And so the idea here is, well, if you have multiple of these things, then you're going to need less pumps, as they kind of illustrate in the book. In this case, it looks like you need the same number of pumps, but if you have a more complex one, you need less pumps here because you only have mixing over here. Um, and in fact, you really don't even, technically, I guess you could say you don't really need, well, you do need that pump. Um, yeah, you do need that pump because you got to get the pressure in here to the same as the pressure here. But as they show in the book, that if you have more complicated systems, you're going to need less pumps here because again, you have a mixing chamber for all of these, not for each one. So if you have multiple of these or open systems, you're going to have a pump for each mixing chamber. Here you have one mixing chamber, so you only need basically you only need one pump to get everything together. So If you have, you just need one extra pump per closed feed water system. So in this case, so if you had 5 closed feed water um, heat exchangers, you still need 2 pumps. But in this case, you need 6 pumps. So again, it's kind of this is not a good example of why of the pump issue here. But again, this you need fewer pumps here, but you don't get, you have heat transfer, you have some kind of cross flow heat transfer. So again, the heat transfer in this thing here is not going to be good as just mixing. Um, Mixing this, this would be uh, saturated liquid here, and then the steam from here to mixing it. Here you basically have this, you're not getting as much good of heat transfer out of it. But again, fewer pumps. So that's basically in the end. In the end, you still do mix everything in the end in either system, but you just don't do um, the heat transfer in a mixing chamber. Again, um, there would be some heat transfer here also when you mix, and again, these have to be at the same pressure. But um, if you add lots of these, then you still only need one extra pump. So to get this and this at the same pressure. Okay, that's probably, I think I said enough about that.